Hello guys, welcome back to our channel ChandraAwesome. So let's continue our RC truck design in the document. So in the previous video we have successfully completed the steering mechanism along with the parts and assembly for this truck. But we have also observed that the angle of steering rotation is getting intersected with the body and the chassis. Okay, but if you want to maintain more steering angle, you have to adjust the body, or else you can adjust the steering rotation to minimum value. That is this much. It is too small, but later we can adjust it. So now let's add the mm, let's focus on adding the motor and drive mechanism to the rear wheels. Okay, so currently these are stable wheels and the assembly is also not completed if you observe it clearly. So let's switch back to the Power Studio, that is RC modifications, and we have to make the design. Okay, okay, cool. Everything is cool. These are the existing sketches, I think. Let's hide the sketches for now. Right click, hide all sketches. So these are the parts. Okay, except this part, let's hide every other parts. Okay, we need only the chassis. Okay, so we are not making any changes here. Just hold on, just undo the operation. We need the shaft. Let's keep the shafts and the chassis and hide the other parts. Okay, so we are going to add the drive mechanism to only this front main wheels axle. Okay, so in order to do that, let's switch back. Let's hide this front plane, we don't need it right now. Okay, let's switch to the right plane, observe it, and we don't know the wheel, how much wheel diameter it is actually designed. So this is the wheel, I think they have it's already designed. But if we switch back to here, okay, the wheel is aligned, so there is no problem. The shaft is in shaft value is more. I mean, the shaft length is high, so we can consider this wheel diameter. Okay, now click on the right plane, select sketch. We have to draw the wheel diameter. We don't know how much, but still we need the one. Okay, so we got the position. Now save it. We are going to make modification to the sketch, but it's needed right now. So let's switch to custom tools. You can find the Spurgate tool, as I already make videos on this tool, how to design gates using this and different approaches as well. So we are going, so right now it is in the origin. Let's switch to circle required region by choosing move origin, selecting the point. Okay, we got the wheel gear, but it's too big. Let's decrease the module to 0.5. Let's see how much it is there. Okay, I think it is perfect. But the thing, but it is aligned to one direction. Let it be. There is no problem here. I think the diameter to zero point 0.5 is enough. Let's adjust the thickness to point 2. Let's keep it let's keep it 1. Okay, let's keep it to that's better. Yeah. Got the gear to this wheel, and you can think that how we can attach the motor here. Actually, we can attach the gear motor to in two possible ways. One is using these die speed reduction gearbox. Okay, it is you can buy it in online, or else we can choose this type of mechanism, like adding the belt drive, or else if you want we can also choose gear drive, or else if you want to choose horizontal or vertical position alignment. For example, I'm thinking to attach like this, so it will be easy for you to attach the motor as well. Okay, so I'm choosing this position. Okay, let's keep the wheel like this. Okay, that's again is enough. Now we have to add, we need one more gear as well. So I'm going to edit the sketch one. So currently it is point 0.5. Let's draw the same circle with construction on. It's point 0.5. Let's draw the other circle as well. Give the dimension to 0.5 mm. It's a zero point 0.5 module. Okay, cool. Everything is cool. Let's observe this. So it is actually 12.5 mm diameter. So it is the sketch 76 and self construction, and give the value to, okay, hold on. Yeah, I give the dimension value to 12.5 mm, just like previous one. Okay, now draw an another circle as well. See construction and make it tangent to it by using tangent constraint. Now give the value to it. So let's give, if we give 5, it is so small. Actually, it is, yeah. Let's keep it, okay, let's keep it 5. Okay, it's 5 mm module. Sorry, the diameter. You have to adjust the gear with this position. So I'm not at constant because later we can adjust the position here. Okay, now select spark gear again. Now choose origin as this point. Hold on, we got the gear. So pitch diameter is 5 mm, and The module I forgot. Just sorry. For 0.5 mm. Pitch diameter, the module is 0.5 mm. Okay, let's in order to adjust the module, we need to adjust the teeth. So we have to decrease the number of teeth here to match with the module. Okay, the teeth is 10. I think this is enough. Or if you want to maintain more number of teeth and more number of teeth, you can also maintain that by adjusting the module. Okay, so I'm keeping the same thickness here. That is 2 mm thickness. Okay, very cool. Now save it. Uh-oh, it's not good. Let's keep it 10. These two and save it. Okay, now the changes got saved. Now let's observe it. Sorry, here the position. It is not currently horizontal. Okay, so we right now we need the actual motor dimensions. So we have several types of electrical motors we find. So based on the motor you're choosing, this gear alignment position should be changed. Okay, so for my suggestions, I'm going to use the available motors. So I'm going to choose uh, 3dfit.com using the using the third party extension for Onshape to find the 3D parts. Okay, so we just need to click on accept all. Now you need to search for the 3D part. Just search for motor, and let's see if you can find any body, any motor parts. Okay, actually we are not finding any. These are completely inbuilt parts. We need a motor. Let's see if we can find. If you don't find here, let's switch to another extension. I think I already made a video about these electrical motors or the third party extensions that will be useful for you. Okay, so these are actually a thing, these are actuators that motors are fixed to these parts. So we need to import any one of the port and take the motor from it. Okay, just switch back from here. I'm going to use other extensions. I've given you the video how to get these all extensions for free, so you can import those body parts within your Onshape CAD software and use it for free. Okay, I'm going to use the trace parts extension. A new tab will be open for you. It's just like a inbuilt browser tab. Okay, just search for motor. So you can find many motors, right? These are all different types of motors. It looks like same, but these are different. The speed reduction motors. We just need a simple one. Okay, no, not finding it. Let's try with other one more we have. Let's try with the other extension applications part community. Okay, let's search here. Uh, oh, we got bigger motors than we actually expected. Okay, we need a DC motor, right? Instead of searching here like this, let's search for DC motor. There we go. Got it, but still the speed reduction motors we are getting. Hmm, which one you want to use? You can choose whatever you want. Okay, let me import this one. You can check the 3D model right itself within the specific 3D viewer. You can adjust the dimensions as well here. Everything you can adjust everything. Okay. Actually, if you'd like to know the dimensions here, this is the length. These are all our mm. Oh, the length is too much. This is 60 mm. This is the minimum value. We don't need this much per motor. Okay, let's try with different one. Let me find it here itself. If still I am not getting, sometimes it doesn't work. Okay, let it be, guys. I don't want to may take more time for just searching. So I'm just going to draw this some random design. So let me search dimensions of DC motor right itself. Simple RC DC motor dimensions. So here we go. It is 2.5 centimeter. 2.5 centimeter and 2 centimeter. This is the actual cube. I'm going to draw it here. Okay. Let's see the distance from here to here. It is 11 point. We have so much distance. And the actual shaft height is 2 centimeter. 2 centimeters too big, no? Okay, I'm just going to draw some random motor here. You can find the configurations of actual motor later. Okay, and you can attach it. Still, it is only for learning. I'm drawing here itself. Okay, I'm selecting this face, selecting sketch, draw a circle at the center to make the shaft motor shaft. Okay, okay, let's give the diameter of 0.5 mm and draw another circle as well to draw the motor. It should be bigger than this one, bigger than the gear. Okay, so let's keep it 9, or let's keep it 10. Okay, let's keep it 9. That's fine. Okay, now save the sketch. Select the face of the sketch. Select extrude. So let's start using offset. Give the value to 2 centimeters. Okay, let's keep 3. Okay, that's fine. Let's adjust the depth. I know the motor should not be this much long, but this would exactly helpful us for us. I'm choosing the precision here, tolerance operations, so you can adjust them later. I'm choosing 0.12, so there should be a distance for 0.12 here from the hole. Well, it is depth. I don't need it for any precision here. I'm keeping as it is new part. Save it. Now visible the sketch 77 again. Select the smaller hole, extrude it to up to this face. Okay, let's keep it blind. Let's adjust the diameter. 20, it's too much. 19, 18. Okay, that's fine. Let's switch to second end position. Give the value to 1, 2. Okay, let's keep it 3. Now save it. So this we got the motor, we got the gear, everything we got it. Now let's do one thing. We have to make a hole to this motor. So I'm using boolean tool. I'm subtraction, selecting the shaft and remove it from this part. So by choosing the keep tools, it the shaft will be stayed there. Okay. Instead of doing separate boolean operation, you can do the same here. These are the tools, and target body should be gear and this one. And save. Okay, everything we got. Even we got this as well. Just a second. Okay, okay, cool. Okay, that's fine. We have to do another boolean operation to make hole here. Choosing subtract, selecting the motor body, and target should be this. And save it. Okay, we got it. Now let's edit it. And this is the target as well. And this is the okay. Now we made changes here. Now we have to do one thing. We have to make a hole to this, or else we have to adjust the depth here. Let's draw a sketch at the bottom. Select rectangle. Choose from this point alignment to this point. Let's constrain it with these lines by choosing line and point and press I letter. While rotating, you should not move left and right? Because the alignment will be changed. So in order to avoid that, we have to draw a center point rectangle here itself. So draw a center line. Now select line tool. Okay, let's keep it construction. A regular line. Choose corner rectangle and draw. Actually, we should. Okay, let's undo. This is this should not be the one. Select point, select line, select construction line, and draw center for these gears. Just make it constrained. Make it center to these gear points. Okay, now it is aligned exactly at the center. Now switch to center point rectangle. Find the center. It will be highlighted and draw some width. Okay. Now give dimension to it. Let's keep the value to 2.8 HDs and save. We need it should be a bit. This region material should be removed. Okay. Match scope this to this part. Okay. I think the gear is aligned to this one. So make sure it is aligned to this part as well. This one and come on, what's happened? Just hide the gear for now. Oops, we need the holy shit. Okay, let's match with this and keep the value to 5. I think that is fine. And now save it. Let's make the gear visible. Let's hide the shaft for now. Okay, there is no hole appeared here. Oh, did a mistake, I think. Don't worry. Let's add a hole right here itself. Select the face, select sketch. use tool to project the actual diameter. Yes, that's fine. Now select the region, select extrude to remove operation, make sure merge with only with the gear and save it. Now show the shaft. Okay, now hide the gear for now and make sure this highlight the sketch or select the same sketch, select add, make sure it should be symmetric and give the value to 5. So merge with these two shafts and save it. Now make sure the wheel is visible again. Now they got fit. Just hide the sketches, we don't need anymore. Okay, we got the alignment, just hide it. Okay, everything is perfect now. Let's do one thing. Select extrude, select thin and select this edge. Give the value to zero point 0.1 mm. Give the depth to 0.1 mm. The reason why I have added these, okay, let's keep testing part. The reason why I have added this part is because in order to make sure the gear is actually should be fit to this region only. It should not be moved either of the sides. Okay, of even the shaft loose. Okay, in order to avoid that, that's why I only have added this extra part. It will apply to the same, but for motors they should fit good. I'm just adding the fillets. Let's give the value to 1. Okay, let's keep the value to 1. That's fine. Let's keep it 0.5. Okay, everything is good. Now save it. Now the last thing we have to do is switch to the assembly and assemble these parts. So I will show you the assembly section in the next video. I hope you understand the concept of how to fit the motor to the existing part for the truck as we did right now, and how to align the gears as well. So let's continue in the next section. Stay tuned and like and subscribe our channel, guys. Thank you.